And now for some simulation. So we're going to start in the most important place, the options. So under System Options General, there is a new option, which is to save the file after meshing and after the analysis completes. This is purely designed to save you if anything goes wrong with your machine, so you don't lose that time spent already. Under Solve and Results, we have some new copy study options, where we can choose to include the mesh and include the results. This is all about saving hard disk space, so if you don't need to copy it, we don't copy it basically. So you're not getting all that extra load. Now, we're going to be doing a study with this chain tensioner. The purpose of this chain tensioner is to take the power from the user's arms and apply it to the wheels. And we're going to be loading up this pulley wheel where the two chains run. So we're going to change back to a different configuration, simplified configuration without all the chains and gear. And I'm also going to enable the chain study. So if I hide away this pin, we can see that underneath there's a bearing. No real surprise there, and there's another one at the back. Now, bearings are usually simplified models because they're pretty complex items. So what I'm going to do is I'm going to remove these two model bearings from the analysis, choose to exclude them, and we're instead going to add a bearing connector to represent those bearings. There's one here already, which is the back one, so we're just going to add the front one in. So I'm going to select the pin, and then with a quick right mouse button, it'll switch the selection box to the second field, and then I can select the second option. Now, there are already some connection types for our bearings, but there's a new one, distributed. It's a new in 2024, and the important thing about this one is it allows the surfaces that are modeled for it to deform. So we're going to add some stiffnesses in, so axial and lateral stiffnesses, and we're also going to add in the new tilt stiffness. So we'll set that to 4.3. We also have a new stabilized shaft rotation option, so I'm going to select that and I'm going to give that a value of 0.002, and that's going to assist or represent how the bearing helps stabilize the shaft. So having added those bearings in, we are going to add the loads in. In the force window, I'm going to hit the pin. This just means that the window stays open while I'm adding forces, so I can add several of them at the same time without having to reopen the command. So I'm going to select the first face, choose 250 newtons, hit the tick, window stays open. We're going to set the second loading face. This one's 150 newtons. And then because this is the last one, I'm going to click the pin and then click the tick in order to complete the command and add both of those forces in. Then going to run this study. Doesn't take very long to mesh, and we've shortened the video so you don't have to watch the whole of the solve. We can get straight into the results. So first of all, animation results, which is moving how we want it. Remember, this movement is scaled, it's not actually moving that much. We can then have a look at the displacement, which is mostly at the back of the pulley block, which may be a bit of a surprise. And we can have a look at the factor of safety across the whole model and also on the pin itself, which at 1.9 is okay, but we may want to bump that pin up a little bit before we go for the whole model.